Everything you were told about dolphins is polite. The smiling face, the playful leaps, the children's books where they rescue swimmers and guide boats home. That image is not a lie, exactly, but it is a fragment. And now, as researchers feed decades of underwater recordings into machine learning models built to find structure in alien-sounding data, the fuller picture is starting to come into focus, and parts of it are not cute at all. This story is not about dolphins learning to speak English. It is not about a computer translating a click into a word. What is actually happening is quieter, stranger, and in some ways more unsettling. Pattern recognition software, trained on hundreds of thousands of hours of cetacean audio, has started to identify repeating acoustic units in dolphin communication that behave, statistically, the way units of language behave. They cluster, they follow rules, they carry information. And when researchers cross-reference those units with the behaviors the dolphins were performing at the moment each sound was made, the content of those communications starts to feel less like play and more like something we did not quite expect to find in another species. The work pulling this together is not coming from one lab. Projects in Europe, the United States, and Japan have all been chipping away at the same problem from different angles. The Wild Dolphin Project, led by Denise Herzing, has been recording Atlantic spotted dolphins for more than 4 decades. Cornell University has hosted related acoustic research. An initiative called SETI, the Cetacean Translation Initiative, has focused on sperm whales rather than dolphins. But its methods are closely related, and its early findings have pushed the entire field forward. None of these groups are claiming to have cracked dolphin language outright. What they are saying, cautiously, is that there is far more structure in these vocalizations than a purely instinct-driven communication system would produce. And the more data the algorithms chew through, the clearer that structure becomes. To appreciate why machine learning is the tool that finally made progress possible, it helps to know what dolphin vocalization actually looks like acoustically. Dolphins produce 3 broad categories of sound. Clicks, which are primarily used for echolocation, function a bit like a biological sonar. Burst pulses, rapid sequences of clicks, are often associated with aggressive or emotional interactions. And whistles, the most famous of the 3, are tonal sounds that carry over long distances and vary in shape from one individual to another. Every dolphin, by roughly the age of 1, develops what researchers call a signature whistle, a unique tonal pattern that it uses to identify itself. Other dolphins can imitate that whistle to call a specific individual, essentially using its name. That one behavior alone, documented for decades, already places dolphin communication in a small and unusual club. But signature whistles are only the surface. Beneath them, embedded in the flood of clicks and pulses and broadband noise, there appear to be much finer patterns that the human ear cannot track in real time. This is where the algorithms come in. Models based on techniques originally built for human language translation, adjusted for the faster timescales of cetacean audio, have been able to segment the acoustic stream into discrete units the way written language is segmented into letters or words. Some of those units repeat in specific social situations. Others appear only in hunting contexts. Others show up when a mother is interacting with her calf. The statistical fingerprint looks, increasingly, like the fingerprint of a system that is doing more than emoting. Here is where the story starts to take its unsettling turn. When researchers cross-referenced identified acoustic patterns with video of the corresponding behavior, several findings came up that were not in the original hypothesis. Specific vocal sequences seem to correlate with coordinated group hunting strategies in which dolphins drive fish into shallow water or into waiting members of the pod. The coordination is too precise and too situation-specific to be explained by general excitement alone. Something in those exchanges is carrying instruction, or at least coordination. And when you realize that dolphins are, in effect, planning and executing group maneuvers through acoustic signaling, the image of a purely playful animal begins to tilt. There is more, and it is the part that people tend to find hardest to sit with. Researchers studying bottlenose dolphins in the wild have documented behaviors that, in any land mammal, would be described as aggression, coercion, and prolonged social conflict. Male alliances that pursue females for days at a time. Infanticide in some populations. Apparent retaliation against individuals who have violated group norms. These behaviors are not new to biologists. They have been in the peer-reviewed literature for years. What is new is the possibility, still tentative, that the acoustic data may show those same confrontational events being accompanied by distinct, repeating vocal patterns. In other words, the machine learning is not inventing a dark side. It is starting to give us a potential acoustic signature for behaviors we already knew were there. That last point deserves to be underlined, because it is easy to overread. No one has translated a dolphin sentence. No one has recovered anything resembling a threat or a command in human terms. The statement being made by careful researchers is much more modest. There are patterns that correlate with specific social situations. Some of those situations are tender, some are cooperative, and some are confrontational in ways we used to associate mainly with primates and a few other highly social mammals. The dolphin is not turning into a villain. It is turning into something closer to what it always was, which is a large-brained, long-lived, intensely social predator, with all the complications that lifestyle tends to bring. Now for the skeptical voice, because this field has no shortage of critics, and several of their points are worth taking seriously. A number of linguists have pointed out that statistical regularity is not the same as language. Weather patterns are statistically regular, so are the songs of certain birds. Finding structure in a signal does not automatically mean that signal carries the kind of open-ended, generative meaning that human language carries. Dr. Eric Kirschenbaum at the University of Cambridge, who studies animal communication, has argued repeatedly and publicly that researchers should be cautious about mapping human linguistic concepts onto cetacean sounds. He's not dismissing the findings. He is insisting on precision, and that insistence is part of why this research is improving rather than collapsing. There is also the problem of training data. Machine learning models find what they are trained to find. If you feed a neural network a massive pile of dolphin audio and ask it to cluster similar sounds, it will cluster similar sounds, whether or not those clusters correspond to anything meaningful inside the dolphin's own minds. The patterns are real, in the sense that the math is real. Whether they reflect dolphin intent, or just reflect consistent acoustic mechanics of dolphin anatomy, is still an open question. Honest researchers in this space will tell you that openly. Even with those caveats, the cumulative picture is hard to ignore. Dolphins have brains that, relative to body size, rank among the largest of any mammal. They pass mirror self-recognition tests. They appear to teach skills across generations. They form long-term alliances. They've been documented using tools, specifically sponges worn over their beaks, to protect against stings while foraging on rough seafloor. They remember individual whistles of other dolphins they have not seen in 20 years. These are not the traits of a creature with a trivial inner life. And whatever their vocal system turns out to be, exactly, it is almost certainly doing more than we assumed it was doing 30 years ago. The disturbing dimension, to the extent that label fits, comes from two places. One is the content of what the sounds may be encoding. The other is the implication of what it would mean to confirm it. On the first front, if the statistical patterns hold up, and if they really do distinguish between categories of social situation, including the harsher ones, then we are looking at evidence that dolphins communicate about conflict, coordination, and intent in ways that go beyond raw emotion. That is not evil. That is not even surprising, if you take seriously what their anatomy and behavior already suggest. But it cuts against a sentimental picture that a lot of people hold, consciously or not, and unwinding that picture is uncomfortable. The friendly mascot of the ocean becomes a complicated social predator, capable of cruelty as well as care. Most large, intelligent mammals are. We are one of them. On the second front, if any future iteration of this research ever does establish something closer to a true translation, even for a narrow set of behaviors, the consequences ripple in several directions at once. Captivity practices, which already face heavy criticism, would come under even sharper scrutiny. Fishing operations that incidentally trap or kill dolphins would become harder to defend on ethical grounds. Military programs that have historically used dolphins for mine detection and similar tasks would face new questions about consent and coercion that currently have no regulatory framework. And on a purely philosophical level, the sharp line our civilization has drawn between human communication and animal communication would start to look less like a cliff and more like a slope. There are echoes here of earlier shifts. Not long ago, the idea that great apes could learn symbolic language was controversial. It is still debated, but the ground has moved. Not long ago, the claim that elephants grieve their dead was dismissed as projection. Now it is documented. Not long ago, the suggestion that crows could plan and solve multi-step problems would have gotten a young researcher laughed out of a department meeting. Now it is textbook. Every few decades, a non-human species steps across a line we did not think it could cross, and we have to redraw the line. Dolphins may be stepping across one of those lines right now, quietly, in acoustic data almost too dense for human ears to parse. None of this means the researchers are on the verge of posting subtitled dolphin dialogue to a video platform. That image is fun, but it misleads. What they are probably on the verge of, if current trends continue, is a much more gradual and much more defensible claim, built piece by piece. Certain calls correspond to certain behaviors with high reliability. Certain sequences carry more information than others. Certain individuals appear to use specific patterns with specific partners. Over time, those small claims stack into a larger one, and at some point, the larger claim becomes difficult to dismiss, even for skeptics. Worth mentioning briefly, because it shapes how this research will be communicated going forward, is the role of open data. Several of the larger cetacean research projects have begun releasing portions of their audio archives to the public, alongside the analytical tools used to parse them. That openness has drawn in independent researchers, citizen scientists, and machine learning hobbyists who would never have had access to the material a decade ago. Some of the most interesting pattern recognition work in the last several years has actually come from outside the traditional marine biology establishment, produced by data scientists who brought fresh statistical approaches to old recordings. The field is becoming more collaborative, more distributed, and harder to bottleneck. That is probably good for the science, even if it makes the resulting claims harder to control for accuracy. What the AI has done, really, is not decode dolphin language in any finished sense. What it has done is make it impossible to ignore the signal. For decades, the data was there, in archives of underwater tapes, but no human team could listen to all of it, hold the patterns in mind, and do the statistical work at the same time. The algorithms can. That is the true breakthrough. The breakthrough is not that machines understand dolphins. The breakthrough is that machines finally let us see how much we do not yet understand. That distinction matters because it reframes what comes next. The next decade of this research will not be an announcement. It will be a grind. More recordings, more cross-referenced behavior, more careful, conditional statements. And slowly, almost without a single dramatic headline, the map of what dolphins are capable of, socially and cognitively, and perhaps even linguistically, will fill in. Some of that map will be beautiful. Some of it based of the water where we rarely swim. They've been doing it for a very long time. We are only now starting to hear it clearly enough to wonder what we have been swimming alongside the whole time.